Everyone, my name is Vikas and I am working as a senior consultant at Infosys. I have overall 12 years experience in the integration world, spanning from TIPCO, Sterling Integrator, and MuleSoft. Okay, and I am a MuleSoft mentor and a MuleSoft certified integration architect. Okay, I love to share the knowledge of MuleSoft, and so I have created my own YouTube channel as well, which is your integration buddy. So here is a link you for that your integration buddy. You can check out the videos that I have posted over there. Okay, and you can connect with me on my LinkedIn as well. Okay, so this is today's agenda. So first we will know that what is a transaction, okay, and what are the mule components which support the transactions. What are different transactional actions? What are local and XA transactions? And then how the threads are managed in the transactions. What is the Bytronics transaction manager? And then finally, we'll go to the demo of for both the local as well as the XA transactions. Okay. So first, let us understand what is a transaction. So transactions are the operations, okay, in which a mule app in a mule app for which the result cannot remain indeterminate. Okay, so all the operations must succeed or fail as one unit. Okay, suppose there are 10 operations in a group, and if 5 fail, 5 succeed, then all the operations have to be rolled back. Okay, either they all fail or they all succeed. Okay, so all the 10 operations should either they should pass or either they should fail. So, okay, so they all the transactions, all the operations in a particular unit or particular group constitute a transaction. Okay, so transactions have four properties basically. Okay, so we have the atomicity, consistency, isolation, and durability. Okay, atomicity means that either all or none. Okay, either all the transactions, all the operations in a transaction should succeed, or all the operations should fail. Okay, so let's take an example like in our online banking system, right? Suppose you are transferring the money to someone, okay, and while transferring the money, you got a OTP. Okay, but once you enter the OTP at that point in time, suppose you lost your internet connection. Okay, so what happens that whatever the steps in that transaction you have performed, okay, like the entering the pay name or entering the amount you want to transfer, all will be rolled back. Okay, because you have encountered an issue like your internet connection is gone, so you cannot continue that transaction. So you will have to restart that transaction from the beginning. Okay, so this is atomicity. Then the second is the consistency. Consistency means that the data before the start of the transaction and after this transaction has ended, it should remain in the consistent state. There should not be any inconsistency in the data. So let's take an example. Suppose you go to the ATM and withdraw some money. Suppose you have like in the ATM and your bank account you have 10,000 rupees and you withdraw 5,000. Okay, so you withdraw 5,000. After withdrawing the bank, the leftover amount should be 5,000. Okay, so it should not be like that, like okay, while you were withdrawing the money, so the money didn't come off the did not come out of the ATM, and the bank balance was debited by 5,000. Okay, it should not be the case. Okay, so the data should remain consistent before the start and after the end of the transaction. So bank was having 10,000 rupees. Now the bank account is having 5,000, and you have withdrawn the 5,000. Okay, so the data is in a consistent state. Isolation means that like multiple transactions can be triggered in parallel, right? So the thing is that the every transaction should run it in the isolation. Okay, they should not be interfering in each other's operations. Okay, so let's take an example. Suppose our code is getting inserted, and then you're performing some update on that inserted record. So until the code is inserted in the database and until the insert is committed in the database, update should not be allowed. Okay, so once the insert is committed, only then the update should be allowed in the database. Okay, so each transaction should run in the isolation basically. The last part is the durability. So durability means that whatever the changes which are committed as a part of transaction, suppose a transaction is has ended successfully and there are some changes that have been committed. So those changes should remain in the system even if the system goes down afterwards. Okay, it's not like that today you're committed the changes and once suppose there are some system failure in the evening, so the changes should not be lost, so they should be preserved. The durability the changes should be there, so changes should be durable. Whatever changes are committed during the transaction, those should still remain in the system even if the system fails afterwards. Okay, so yeah, hope I am clear on this all these properties. So what are transactions and what are its properties? Atomicity, consistency, isolation, and durability. So let's move forward. So what are different transaction types in Mule? Okay, so there are two different transaction types in Mule. One is the local transaction, another is the extended architecture or the XA transaction. So what is a local transaction? Local transaction means that all the operations in that transaction will belong to a single resource. Okay. Suppose we are taking example of the database. Okay. So all the whether we are doing an insert, whether we are doing an update, or whether we're doing a delete, so all the operations for should belong to the same database configuration. Okay, so you should define just one config file for that, one configuration for that database, and all the operations will be using the same global configuration. Okay, and these local transactions they perform better than the XA transactions. Okay, because obviously XA transactions include the multiple resources and their operations, but here in the local it will be only having a single resource with multiple operations, so it performs better than the XA transactions, and it does not support a nested transaction. So within a local transaction you cannot have another local transaction, so nested transactions are not allowed in the local transactions. Now what are the extended architecture XA transactions? XA transactions means that there is involvement of more than one resource, okay, in this XA. Okay, so the either it can be a database or it can be JMS or VM. So all these components which are supporting the transactions form are part of this XA transaction. So XA transaction involves a two-phase commit protocol. Okay, so it's called a 2PC, two-phase commit protocol. So what it is, I will explain you in the later part of the slides when I explain about the Petronics transaction manager. Okay, so I'll explain that one in time about this two-phase commit protocol. So since in this extended architecture in this XA, we have since it guarantees a reliability. Okay, so the operations will be performed consistently across the different resources, but it is slower than as compared to local. Obviously, because it has to coordinate among the different resources. Okay, and their operations, so it is a bit slower than the local, but yes, it ensures reliability. The all the operations that are getting performed across different resources, those will result into a consistent state of the data. Okay, and it supports nested transactions. So unlike the local transactions, which was not supporting the nested transactions, this Axis supports nested transactions. Okay, let's move forward. So these are the different transactional actions. Okay, so which are supported in Mule. So let's just go through this documentation link and explain you better about this. So let's copy it. So these are the different transactional operations basically. Okay, so what is a transactional action? Transactional action defines a type of actions that operations take, okay, which in the transactions basically. So here is a one action is a always begin. So this is available for the listener, that support transactions and in try scope only. So what it means that always begin means that the transaction will always be started. Okay, but if the transaction is already in progress, then we will get an error over here. Okay, so in this, in the case of the local transaction, but in XA, if the transaction is already started, then a nested transaction will be started in XA. Okay, in the case of always begin. Then there is always join. So always join means that always expect to join a transaction in progress when the message is received. Okay, so always join means that if we set this, this is always join the operation, the resource always assumes that the transaction is in progress and the resource has to just join that transaction. But if the no transaction is in progress, then an error will occur. Okay, then there is begin or join. So begin and join means that if transaction is in progress, join the transaction, otherwise if possible start a transaction. So this is available in the try scope. Okay, join if possible, it means that join the current transaction is available. Okay, but if its transaction is not in progress, then no transaction will be created. The operation will not be able to join that transaction. Indifferent means that do not treat action as a transaction. Okay, so it will not be considered as a transaction if we set it the transaction action as indifferent. None means do not initiate a transaction, and not supported means okay, that operation is no, we will not be supporting the transaction. So these are different transactional items and the description, and these are the different components which are supporting these transactional items. So some are supported in try scope, some are supported in different operations, some are supported in the listeners. So here I have mentioned clearly here what is a try scope supporting. It will be supporting indifferent, begin or join, or always begin. Listener will be supporting as none or always begin. Operations will be supporting not supported, join if possible, and always join. Okay, so operations here refer to the database operation or the VM operation or a JMS operation. Okay, so here is the what are the mule components, which are the modules which are support the transactions. So along with the try scope, below modules support the transactions in MuleSoft, database, JMS, and VM. So all the operations inside database, whether it's insert, update, delete, select, DDL, stored operation, procedure, query, single, whatever I have listed, all the operations inside the database, they all support the transactions. JMS, we have these three operations who are supporting the transactions on new message, publish, and consume. And VM, we are supporting listener, publish, consume, and publish, consume. The ones which are marked in yellow over here on table row, on new message, and listener, those are the basically the listeners. Those are the starting processes, basically starters of the transaction. Okay, apart from these three, all all are not the starters of the transaction. So on table row, on new message, and listener are the starters for the transaction. So how do we manage the threads in transactions? Okay, so I hope you are aware of the threading mechanism in or the thread types in Mule. So here we have the different types of threads that are available in the thread pool, which are the CPU light, CPU intensive, blocking IO, shared grizzly, and dedicated grizzly. Okay, so here, if you see that in a typical thread switching scenario where the transactions are not involved, how the thread switching happens, and when the transactions are involved, how the thread switching happens. Okay, so here you see that the HTTP listener. HTTP listener will always be using a shared Grizzly thread. So it picks up a shared Grizzly thread from here, and then it perform a database select operation. All the operations on database would use a blocking IO thread. So it uses a blocking IO thread over here. Logger, because it's a light operation, so it will be using a CPU light thread. Data weave will be a CPU intensive thread. Logger again with a logger and then HTTP requester will both be covered under the CPU light thread. Okay, and then HTTP requester will respond back with the dedicated Grizzly thread. Okay, so these are different threads which are being used by different components. Okay, so without a transaction, but if we enable a transaction, in that case you would see that there is a blocking IO thread being used throughout this complete transaction. Okay, so once this HTTP listener uses the shared Grizzly thread, it hands over the execution to the blocking IO thread. Okay, so blocking IO thread will complete whether it's a database select, logger, data weave, database insert, HTTP request. All these things will be performed by the blocking IO, because the thing is that the blocking IO, because in transaction all should fail as a unit or should succeed as a unit. So that's why the complete operation in a transaction will be performed by this blocking IO thread. Okay, so you can learn more about this thread management in this the link which I have pasted over here in the slide. Okay, just quickly show you what it is. Okay, so it has been so this thread, this link is having the information about the different thread types and the uh, the threading with the transactions. So you see over here that this is in the blocking IO, and in case of JMS transaction, again this blocking IO will be used. Okay, so just keep it simple. Like in the case of transaction, a blocking IO thread will be used to execute the transaction. Okay, so let's move forward. Okay, so coming on to the Bytronics transaction manager. So in the XA transactions, right? So XA transactions, we learn about as I told in the beginning. So it involves a two-phase commit. Okay, so two-phase commit approach is there in the XA transactions. So how does it work? Two-phase commit means that in the first phase it will be resource will be prepared to commit, and second phase the changes will be committed. Okay, so we have the resource manager for every operations which are for every resource which are taking part in the transaction. For database we have different resource manager. For JMS or VM operations, we have the different resource manager. So these resource manager coordinates with the transaction manager. Okay, in XA. So transaction managers which Mule uses is the Bytronics. So whenever we commit the changes in the transaction, okay, this Bytronics transaction manager coordinates with the resource manager to commit the changes in the respective resources. Okay, so how do the changes are get committed and how it's ensured that the data consistency is maintained? I'll explain now. Okay, so suppose the transaction gets committed and Bytronics transaction manager now it's trying to execute a two-phase commit approach here. So it issues a message to both the source managers to prepare for commit. Okay, so what happens in the prepare phase? In the prepare phase, the source managers would write down in the transaction logs, these are the transaction log files, which changes they are going to commit. Okay, so these are the temporary files, transaction.log, tx.log, and tx.log. Okay, so they will prepare their respective ts log files, and they will write down what changes they are going to commit in these files. Okay, so once they write the data in these files, the prepare phase is completed, and they will inform back to transaction manager, okay, we are done with the prepare phase. Now the transaction manager will issue the commit command. That's the second phase. So in the second phase, both these resource managers would ensure that the changes are committed into the database or onto the JMS or VM. Okay, so changes are committed and we are good. So two-phase commit approach is like it's completed. So it's a happy case scenario. Okay, so now let's talk about the failure here. Suppose the prepare phase was completed successfully. We got the temporary files also over here. We have the log files and transaction log files. Temporary files are there, and during the commit phase, this commit happened successfully. Okay, but this commit for JMS or VM, suppose the JMS or VM went down or crashed, and this commit did not happen. Okay, so this commit is happened, but this commit did not happen. So the data is now is in the inconsistent state, because either they should pass, succeed as a unit, or they should fail as a unit. So now what will happen? Whenever this JMS or VM comes back online, Bytronix transaction manager would ensure that whatever the changes those which were written in the transaction.log, those are committed into JMS or VM. Okay, so that the data consistency is maintained. So it is the responsibility of the transaction manager to make sure that whenever this JMS or VM resources come online, the changes which were in the transaction log file which was created during the prepare phase, those are committed. Okay, so that the data consistency is maintained. So this is the two phase commit approach, how it is ensuring the data consistency. Okay, so since this transaction manager needs to coordinate with the different resource managers, so obviously it's quite a slow process, but yes, it guarantees the reliability. So it's slow as compared to the local transaction. Okay. So how do we configure the Bytronix transaction manager? It's very simple. You just go to the global elements and just search for the Bytronix transaction manager, and it will appear over here. That's it. Okay, and I'll show you how to configure. Basically, very simple process. And then a single instance of Bytronix transaction manager is associated with each Mule runtime. So every application which is hosted on that Mule runtime will share the same Bytronix transaction manager. And how do we configure the Bytronix transaction manager in a Mule domain? So because we can't configure them individually, right? When we are using a Mule domain, we can't configure the Bytronix manager individually in all the applications which are associated with the Mule domain. So what we do that we define the Bytronix as a transaction manager in the domain configuration file. So here you will need to add this in the domain configuration file. Okay, so this is a link again I have pasted down here, so which lists that how do we add the Bytronics manager in the, sorry, not copied the link basically. Okay, this is the official documentation for MuleSoft. So it's written over there that it says mentioned over here how do we configure in the domain configuration file, how do we configure the Bytronics transaction manager. Okay, now how do the different scopes behave in the transaction management? Okay, the async scope, it is not a part of the transaction manager. Okay, so suppose if you mentioned on async block while running a transaction, so async will run independently in a different thread, so it will not be a part of the transaction until successful. Yes, it's a part of the it's a part of the transaction manager, so it supports a transaction. Okay, when running a transaction, it blocks it blocks a thread and uses the blocking IO thread to complete the transaction. Parallel for each, yes, it supports the transaction. So what happens in parallel for each? It does not execute in parallel. Okay, it executes one by one. Okay, batch processing, it is not supporting the transaction management. Okay, it's designed to work on parallel as similar to the async scope. Okay, here in batch processing every code is treated transactionally. Okay, so it's so batch transaction is not a part of the transaction. So async and batch processing do not support transaction manager with transaction management, whereas until successful and parallel for each do support the transaction management. Lastly, we have the scatter gather. Okay, so this is a commonly asked question in the interview as well, whether the scatter gather supports the transaction management or not. So the answer is yes. It supports the transaction. Okay, so what will happen in the while during the execution of this scatter gather, it will not execute in parallel. Okay, so the first route will be executed first, and if it is successful, only in that case the second route will be executed, and so on. So all routes will be executed in the sequential manner. Only if the first route is successful, second will be executed, and only in the case first two are successful, third will be executed, and so on. Okay, so scatter gather do support the transaction management. Okay, so that's what I wanted to cover in the theory part. So any questions we have? Dhruv. Okay. So the HTTP request, those HTTP request does not support the XA transaction, basically Sagnik. Okay, so for interacting with the HTTP request, and we have to follow the Saga pattern. Okay, so Saga pattern is used for the operations which are not supporting the XA. Okay, so Saga pattern, Saga pattern is of again of two types: orchestration and choreography. So yeah, so you have to follow it will not the HTTP request will not support the XA. We will have to go for the Saga pattern over there. Hope I answered your query, Sapnik. Yep. So it will be handled through Saga. Yep. Yep. Okay. Fine. So let's start with the demo part then. Okay. So first we have the local transaction management demo. So what I am doing over here is that I'm just getting a request, okay, in the HTTP listener, okay, and I have configured a logger just to uh, just log that okay, the transaction is starting. Then what I'm doing that I am inserting a data into an employees table. Just write employees, okay, and then in the transform message I have a condition here. Okay, so just to whether fail or succeed the transaction. Okay, and in the payload I'm just writing that okay, the transaction is successful. Okay, it's a simple. You see that only insert operation is getting performed, okay, for a database. Okay, so but how does the configuration look like? Let me just show you. So I'm using a MySQL database. Okay, so I'm using a MySQL database. So I'm using MySQL database driver, localhost, host port, user, password, database details I have provided over here. Okay, so it will not be an XA. So if I go over here in the try scope, so this is a transaction action which I was referring to. Always begin or join or indifferent. If we select indifferent, transaction will not be started. Okay, so either can be always join or begin or join. So since there is no transaction which is in progress, so we'll be sticking to always join. So always begin. Okay, transaction type is local. Okay, we are not going to see that XA here. Insert. Here you see that in the advanced transaction action, join if possible, always join, and not supported. Okay, so I'll just stick to join if possible. Okay, if I select not supported, this particular insert operation will not be supporting the transaction. Okay, always join, as you already know that it always assume that the transaction is in progress and it has to join it, but it will result into error in case the transaction is not in is not in progress basically. Okay, so I just stick with join if possible. Then transform message is just a simple code I have written that if one is equal to one, then just mention here to trigger an error scenario. That's it. Okay, so one equal to one. So we know one is equal to one, so it will return data insert success. Okay, so fine. So I'm getting the values from this my postman here: first name, last name, department, designation, city, country. Okay, and I'm inserting it into my table which is called employees. Okay, so this is the employees table. Okay, as of now nothing is there. Okay, so just quickly see this. Always begin local, then try Insert is there, join if possible, fine. And I'm storing the result into a insert result variable, transaction manager, payload, fine. So yeah, let's run it in the debug mode. I'll just include a breakpoint here. Okay, we want to switch to the debug. Okay, here I just include a breakpoint. I just sent a request. So the request has come over here. Okay, I'll just move it to the next step now. Insert is done. So can we just check in the database table whether the insert is reflecting? Let me see. You see, insert is still not reflected because we are still in the try block. The transaction is not completed, so the insert is still not reflecting in the database table. I'll just move forward and then just come out of the transaction. Okay. So now I will just search for it. You see that first name Vikas Sharma IT Escon Mohali India is inserted. Okay, and I got a transaction is successful message as well. Okay, the same message I sent in the payload. Okay, so this is a case of the local or the local transaction. Okay, so until the so it has if it would have failed, then node code would have been inserted into the insert in the table. So let's check now. Just check once. Now let's check a failure scenario. So what I will do that if one is equal to one, in that case I'll just fail it. I'm generating an error over here saying that okay, if one is equal to one, just fail and send a message data insert failure. Okay, so let's see how it behaves. Oh, I stopped earlier. Okay, fine. Let me just try to run it again. I'll just change the record as well. Let me just Rahul. Yes. Fine, it's deployed. Let me just send this. So we have come to insert. Let's move forward. So at this point in time, we should not see anything in the training.employees except that one report that I inserted earlier, still there. Okay. So now this is an error. Okay, because I have deliberately failed this. So it is an error now. It has come out of the try block. Okay. So now if I see over here in my training.employees, the data is not inserted. So this try block has failed. Okay, and I got this data insert failure message. Okay, which I wrote over here. Data insert. Okay, so this is how the local transaction will work. Okay, so now let's try another scenario on error continue. Okay, so in the error handling, I'm mentioning an own error continue, and I'm setting on payload here. Okay, saying that we are in the continue block. Okay, now if I run it again, so does anybody knows like what should be the output in output now? What, how will this tribe will behave? Anybody? Okay, will be committed to DB. Anyone else? Okay, fine. So let's see how it behaves now. Okay, so I'll just put. Okay, let's now honey. Let's new name honey, and let's send this now. Okay, it has come over here. Let's move forward. As expected, it failed. Now it will go to the continue block. It will continue, will come out. Okay, so let us see what is that. We are in the error continue block. Whatever payload we set in the on error continue payload, we got it back. Now let us check in the database. See, second row was inserted. So you have to be careful what you are, how you are handling the errors basically in this try block. Okay, if you want the transaction to be rolled back, you have to stick with the on error propagate, or because the default error handling is already on error propagate, or so you have to stick with that on error propagate. If you are using on error continue, in this case it means that I hope you are aware of some of these this different error scopes. On error continue, it means that even if the error occurs, just continue the transaction. Okay, so in this case, since we have used error scope as on error continue, the transaction was not rolled back. Instead, it was committed to the DB. Okay, so just make sure here that you are using the appropriate error scopes while working with the transactions. Another example which I want to show is for the scatter gather. Okay, so scatter gather, right? So you know, right? So scatter gather, both are like these routes should execute in parallel. Okay, if they are not in the, if they are not a part of the transaction. Okay, so but here, what I have done is just stop it. Okay. So here, what I have done in the try block. So try block is always begin and it's a local transaction. I have put a scatter gather here. Scatter gather, there are two routes. Both are inserting the data into the table. One is inserting data into the table called employees. Okay, and another insert is for the employees underscore replica. Okay. However, in the second route, what's happening? Okay, I am raising an error. If one equals one, fail. Okay, so the second route should fail here. Okay, so it's just a logger saying that insert to completed, and then in the end I'm setting a payload saying that insert operation successful. Okay, so let's see what happens this case. So scatter gather I have enclosed in a try block. Let me just debug it. Anybody guys, how will this behave? Any idea how this scatter gather will behave in case the second route fails? Okay, first row will be inserted. Okay, Anyone else? First row data will be rolled back. Okay. Okay, fine. Let's see what happens. Uh, this is still running, still in the debug mode. Okay, basically, I had changed the log4j XML to have the debug instead of info, so it's taking quite a time. Okay, so let's just take a look. Okay, now it's fine. It's running now. Okay, so I'll just send this request. You see over here one more thing which I was talking about, the thread management. Since I'm running in the debug mode and I have enabled a debug mode in the log4j XML also. Okay, so you will see these detailed logs over here. You see that once we entered into this try block, this blocking, these were the thread I was talking about. Blocking thread has taken over. So all the operations under the stripe block will be executed using the blocking, blocking thread, blocking IO. Okay. So now first insert is there. Let me just go to next logger. Fine. Then second insert. Let me just check in that first table whether something is inserted or not. We were having two records, so no, nothing has been inserted. Second one is replica. So let me just see what is replica is currently holding. It is not holding any records. Okay. So now let's move forward. As expected, error is raised. We are now out of the try scope. Okay. So now let me just check what happened to these tables. No new record was inserted. No new code was inserted. Okay. So either both should be inserted, both should succeed, or both should fail as a part of this transaction. Okay. So this is how the scatter gather will behave. Okay. So now similar to the other case which I showed you earlier, you can have an own error continue here in the error scope. Okay. In that case, the both the records should be inserted. I can just quickly demonstrate that as well. Yeah. Yeah, let it get started. And in the meantime, we can take any questions, guys. Yep, it started now. I'll just send a payload. Yeah, let's see what happens. First insert, second, then we put an error, then we should go to the one error, continue, set the payload, then out. You see, the code got inserted in the replica, code got inserted in the replica. Okay, so this error scopes play a crucial role how the transactions will behave in the try block. Okay. Okay, we are done with the local transactions demo. Let's move forward to the XA one. Before we move to XA, any question, guys? Okay, if nothing, then
No question, yeah.
okay, okay, Dhruv, no worries. So let's move forward to the XA now. Okay, just close these. Okay, okay. In XA, right? So XA, as I told you, so it will be different resources that would be uh, taking part in the transactions here. Okay, so what I have done over here, you see in the try block, I have mentioned the transaction type as XA, transactional action as always begin. Okay, then I am inserting the data into a database table, and here into another database table. Okay, the thing is that if I look in that database compo, but both these tables are using different database configurations. Okay, the key thing to note here is that in local, the every operation in the resource would use the same configuration file, but in XA they'll be using a different configuration file because those will be different resources. Okay, so in this case, you see that in the insert, if I go over into this database config, okay, localhost host port user password and database I've considered as training. Okay, so training is this database training. Okay, and then for this one I'm using another configuration, training 2 as a database, which is this one. Okay, so these two different configurations are used. We have to use here the XA transactions. Okay, so again in the advanced I have just put join if possible. Okay, and in insert advanced join if possible. Okay, in the transform message, I'm just saying that okay, I'm raising an error. If one first let's check the success case, and then I'll show you the failure case. Okay, so here we have the insert. So if I go to the database configuration in the transactions, you have to tick mark this use XA transactions. Otherwise, this will not be considered as a part of XA. Okay. Similarly, for the second database, you have to tick mark this use exit transactions. Okay. So now, yeah. So let's run it. This is the employees table. We are using training.employees, and here I'm using the training2.employees. Okay. So let's debug. This XA. I'll be just inserting these details. Arnab Ghosh, architect, Nagpur, India. Okay. Let us switch to the debug mode. Okay, and I'll just truncate both the tables over here. Nothing is here. Nothing is here. Fine. Okay, we're all good. Let me just have a breakpoint. Okay, so let's move forward. Insert, then logger, then again insert, logger, and then transform will be a success this time. Set payload, all good. Insert success, and I'll just check both the tables. Armor coach is there, and then armor coach is there. Fine. So we are able to insert the data in these tables now in both the databases. Now what I will do, I'll just raise an error over here. I'll just one equals one. Success. Okay, so let it run again. Any idea, guys, what will happen? So data in the both the databases are inserted successfully, but we got an error over here. So what would happen now? Any idea? Both will be rolled back. Okay. Anyone else? Fail to insert in both. Yes. Okay, so that should be the expectation. Let's see. I'll just change the name to Amit Kumar. Let me send this data. Come over here. Next step. Next. Next. I'll just quickly check the tables now. One record. One record. Got the error. Now in the outside. The data insert failure. And let me check the tables. You see, nothing is inserted in one database, nothing is in second database. Only one record is there, which was prior to the executing this transaction. Okay, so this is how in multiple databases, the operations in multiple databases would work in the case of XA transactions. Okay, let's take one last example. Uh, Here, what I'm doing, just one second. Yeah. So here what I'm doing that along with database, I am using a VM connector as well. Okay. So as you know that as I told, right, so there will be like JMS, VM and DB, so they can participate in the transactions. So what I'm doing, I'm just sending the same payload. Okay. Here I'm sending a payload and it is calling publish consume operation here. So it is listening for that payload. It will be inserting data in the database and then it will be publishing to another queue. This and it will listen by this queue. Okay. So let us see what happens. So data is getting published. We are publishing it firstly on the Q1. Okay. And then this publishing will be done on the Q2. You see Q2. This is listening to Q2. This is publishing to Q2. Okay, and then the same thing. It's publishing to Q1, and this is listening to Q1. Okay. Yeah, one thing I forgot to tell you. So in the global elements, you have to make sure that you have this Pytronics manager. If I just delete it, I just create one. Just you just search for Pytronics, just click on it, and okay, that's it. Nothing more you have to do to add Pytronics transaction manager. Okay, so if I go to this VM, you have to make sure that transaction action should be join if possible, okay, or not supported, or always join. Okay, so just keep it default to join if possible. Okay, similar for this listener also. Go to advanced. Listener will always begin. Okay, so it will be a starting point of the transaction. As I told you, right, the listener will always be having the always begin. Then for this case, join if possible. Okay, and for this listener will be always begin. Okay, so this is advanced and this is XA because it's having multiple resources, database and VM. Just check the advanced settings. Fine. And this is also fine. Join if possible. What's happening in the transaction message? If one uses success, a happy scenario. I'll just debug it now. I'm inserting data into a table employees. Okay. Yep, it started. So let me just send this payload. Okay, I think the endpoint I need to change is XAVM. Okay, so publish consume feeds comes to listener, comes to insert. Next processor, let me just see if anything is inserted into the table. No, it's old one code that we inserted earlier. Yes, success is time, then the data gets published to this queue, the payload is returned, data insert success, and then just check the table. So see, the new record Amit Kumar got inserted. Okay, so now what will happen in case of failure? Just failing it. So, okay, saved it. Try again. In the meantime, it's getting started. Any question, guys? Yes, Pytronics Transaction Manager. Yes, it should be added for XA only. Yes, just run it again. Still starting. Yeah, it's not started yet. Deployed. Okay, let me just send this again. Change the name. Send it. About the payload. Just just go on by the insert statement. Let me just see if anything is inserted into the employees table. Employee name is Chandan. So it's not there. You see, it has failed. It has not published data to publish queue as well as it's not in the table. You just see that. Yep, it's not there. Okay, so yeah, so that's what I wanted to cover for the local and XA transactions. And you might be having a question, right? So what about the resources which are not supporting these XA transactions, right? HTTP requester, right? So in that case, we follow another approach which is called the saga pattern. Okay, so that which are those are not handled in the XA. Okay, okay. Any question, guys? We can take it up.
Yeah, because we have a questions from Srikant.
Yeah, Shrikant. Can you place on or continue? Yeah, same behavior will happen now if you place in on or continue. That's what I shown here in the database transactions now. So if I place it over here, the transaction would continue. Okay, so yep, so you can try different combinations over the error scopes with the on error continue or on error propagate. So those play an important role how the transaction blocks will the try block will behave. Okay, any other question, guys? Yes. So yes, yes. So Saga pattern, the additional configuration has to be done. Yes. What I can do, Venkatesh, I can ping you after this meeting, okay, on maybe on LinkedIn, and can provide you additional information on Saga. Okay, it's an advanced topic. Okay, but yeah, I can ping you the links to how from where you can get information more on that Saga pattern. Okay. Okay, guys. Any questions before we wrap up?
I think all are good. Yeah.
Okay then. Thank you through for your time then. Thank you.
Thank you guys, and have a nice weekend.
Yep.
And
Thank you.
if
Bye
you
bye.
want to interest in any represent any session, just let us know so we can create a plan or platform for you. Yeah, thank you for joining.
Thank you.
Thank you
Bye
because
bye.
it's a
Thank you.
lovely session.
Bye.
Thank you
Thank
for your timings.
thank you. Thank
Bye
you. Bye bye.
bye.